Hi, I'm Chris Homerding.
And I'm Zach Metzner.
And I'm Dillon T. Joe.
We are part of Christopher Cunning's physics class at Wilmington High School. We're going to be trying to find how far we can throw a baseball bat
And
using our IOLab, using 2D motion, you know. Shut up, Chris, I'm talking. Okay.
and we're doing this because when we get,
We all play baseball at Wilmington High School, and sometimes when the pitcher decides to throw a ball at you, you don't have a fun time, you just want to chuck the bat at them.
gotta go Camp Murphy.
Yeah.
And if you look over by Dillon and Chris, you will see how we set the album on our arm. We taped it on our arm, like right here, put it in the X direction, and we measured it as we released the bat.
Our hypothesis is that Dillon T. Joe, will throw the bat the farthest because
I thought I'm Dillon.
Dang it. Well, okay. Zach Metzner is the weakest, so we'll throw this shortest distance. And Chris Homerding will be in between because, I don't know.
He's average.
He's average.
You rock into a Headshots production.
It's something about you, girl, that just makes my head wanna twirl. Oh, you got me want to tell all them other girls there's nothing else better on this world. The moment I seen her, I was in shock. So shocked you wouldn't think that I've just been shot. Shot down right down in this spot. But too precious doesn't happen a lot. Oh, baby, you got me visualizing me on top. On top of your body, you all was sweating a lot. Another time I got before we would have to stop.
This is the graph of my throw. The beginning highlighted portion is where I start my throw, and I had an average acceleration of 17.72 meters per second squared. The end highlighted portion is where I let go of the...
This is the graph of my throw, and the shaded area of the graph is the acceleration throughout my entire motion of my throw, and we use this to find the speed of my throw, and the acceleration that we got of my throw is 13.49 meters per second squared.
This is my graph where I threw the bat. As with the other two, we took the highlighted portion to find the acceleration, and my acceleration came out to be 11.81 meters per second squared.
This triangle is the initial launch of our bat, and the hypotenuse is the initial speed at the bat movement is moving. On the right is the y component of its speed, which is the sine of theta, which is the angle of the throw, multiplied by the initial speed, which is the hypotenuse. And the x component is the cosine of theta, multiplied by the initial speed.
To find the time, we use the formula delta y equals VOT plus 1/2 AT squared. We then use the quadratic formula to find the time, and the time for each individual person. For Dillon, it was 1.7 seconds, Chris was 1.5 seconds, and I was 1.
To find the displacement of x, we used the time that we solved for before, and we multiplied it by the initial velocity in the x direction to find our displacement of x. And for Dillon, we got it to be 25.79 meters. For Chris, we got it to be 17.5 meters, and for Zach, we got it to be 13.7 meters.
Our data seems plausible because these are theoretical, and we're not assuming wind resistance is affecting the bat too much or any other outside forces. And since the pitcher's mound is roughly 18.6 meters away from the batter's box, my throw would have definitely hit the pitcher, while Christopher's would have came up just short, and Zach would have looked like a fool